Hello, this is Professor Gibson, and this is a video on Chapter 5, Section 4 for Math 114. Okay, so Chapter 5, Section 4 is about working with data when the data doesn't form an exact perfect line. In the real world, it rarely does, all right? So the term for finding the equation of the line, or the best equation of the line, is linear regression, all right? In the book, it says in the real world, quantities do not usually vary in a perfectly linear fashion, okay? And that's true. For example, so if you look at this here, here's the data on the left. It's Social Security outlays and real expenses the government pays out in Social Security by year from 1975 to 2017. And you can see when they plot the graph over here, this is not a perfect straight line, right? In reality, this is closer to one. In my experience, this is closer to a perfect straight line than you usually get, but it's not perfect. There's no matter how you drew a straight line, it wouldn't go perfectly through all those points, right? That's how data in the real world usually goes. So the next question is, what can you figure out? This kind of thing. What would you do? Um, how could you figure out the line that best fits that data, goes with it the best? Okay, so this is the term for this is the thing is this linear regression. It's a way of solving it. We're not going to do it. It's messy, nasty equations, and in the real world, pretty much everybody uses Excel or something like it. So we are going to do it, but we're going to use Excel to do it. Okay. Now, there are two different ways to do this in Excel. You use the first method if you need a graph with the line on it, and use the second method if you just need the equation. All right, so the second method's quicker if you just need the equation. But sometimes you're going to be asked, you can see you're going to be asked about a graph and a line, and the first method will get you both. All right. Okay, so what this says is entering the data from table 5.6, that's this table over here, into a spreadsheet. We can create a scatter plot and then add a trend line by using the Add Chart Element menu under Chart Tools. All right. So you might want to take a moment, pause the video, write these phrases down, add chart element, and then under chart tools, design, these words that are in here, all right, select trend line and more trend line options. Okay. All these words that are in italics are B command type things I'm going to use. Okay. So here we go. Now I have already entered this data into a spreadsheet. There's no need to sit here and watch me type that in. Here it is. Okay, so we're going to do this two ways. Once with the years as they are, I'm going to show you that. And then we're going to go ahead and put in the years since 1975, right? 0 and then on up. And you're going to see why we do that, why we put in the years since the first year. It gets us, it makes the intercept be much more useful. All right, so you highlight the data, including the headings. Click Insert, and then come over here, see where it says Charts, and pick this one that has, I think you can just see if you hold your mouse on it for a moment, it says Insert Scatter. Pick the first one. Okay, now I'm going to click down and drag it over a little bit. Notice to put the headings in for us, Social Security and millions of dollars at the top. I'm not sure why years didn't show up at the bottom. It should have. Okay, and you see there's our line. There's our dots from before, right? Now we're going to get the line and the equation of the line. So this was the next thing I talked about. Up over here on the left, it says Add Chart Element. Left click on that. Come down to Trend Line. And you see when you hold over it, you get some options, and we're going to draw a straight line, so click Linear. There's our straight line, right? And you see it does really kind of go right through the middle of them, above some points, below others. Now we want the equation of the line. Come back over here to Add Chart Element, and then come down to Trend Line and hold it for a minute. And if you see all the way at the bottom, it says More Trend Line Options. So we click on that. This new thing comes out over here. Okay. And all the way down at the bottom, just about, you see where it says Display Equation on Chart. Click on that. There it is. Actually, you can kind of grab this and drag it up a little bit if you want. I'm not sure why, but it always makes them so that it overlaps with the points. Now here's our equation in slope-intercept form. Y equals 20559x minus 4. That's that scientific notation. E plus 0.07. So this is really minus 40 million. Well, that's a slope. So that's the y-intercept, right, of minus 40 million. What's happening, because our year we wrote it as 1975, it's trying to project back in time all the way to the year 0 for the intercept, which really isn't meaningful because we don't really know anything about what's going on in year 0. That's way too far away. Okay, so this is why we change the years, right, to be what they are, to be years since the beginning of the data. Okay, so watch what happens if I do copy, right click, paste values. Look what happens to the, see the slope is the same. The y-intercept is now negative 16,869. What that is that that's the starting value, or that's the value in year 0 on our fitted line. Now, it's not quite the same as the data, right? The data was 64,658, but the line goes in below that, and it'll tell you it's minus 16,000. So this is now a real initial value or starting value. That's why you set your years, your time as your years since the beginning of your data. All right. Now, next thing. So you can see that was how we got it, right? That was the whole process. You can rewind this and watch it again. You've got all those terms. Remember back over here, this has all the little terminology that I just used, right? Add chart element, select trend line, more trend line options, all of that is there. Okay, now, let's say you don't need the graph. There's a faster way to do this if you don't need the graph. We're still going to get y equals, we're going to get in slope-intercept form, okay? So what we do is for the slope, the command is actually slope equals slope. It's pretty easy to remember. Open parenthesis, and then you highlight the y's first, type a comma, highlight the x's. All right, close parenthesis, enter. There's our slope, and you'll notice it's exactly the same as the slope over here. It's just it goes to a couple more decimal places. If you rounded this to the nearest whole number, it's exactly the same, and they will be the same. You want the y-intercept equals intercept. Open parenthesis, same thing. Highlight the known the y's, comma, highlight the x's. All right. There's our slope intercept. You can just write y equals mx plus b from that. And if you round it to the same whole number like we had over here, it's exactly the same. It's just a lot quicker because we didn't have to go through all that stuff with making the graph. Now, there is a forecast command also that's very nice. You know, they tend to ask us often, well, what would the value of y be at this point in time, or, you know, for this value of x or whatever. Well, that's what forecast does. So if you type equals forecast, okay, and you notice here it says x and then known y's and known x's. So you have to put in the x value first. The interesting thing here, the forecast really is the future. You can use this for in the past on this thing too. Like for example, if you wanted to know what the line says the value was, let's say you missed the year missed the 40th year here, right? So if I put in 40, comma, and then we'll do the same thing as before, the y's, comma, and then the x's. There's the y value at 40, right? And you can round it down to a whole number or whatever. On the other hand, you can do the future. So this only went to 42. So what would this say when it was 45? All right. Well, so you just come in here instead of typing in 40 to begin with, type 45. And there's the projection for 45, right? For the 45th year. Okay, so equals slope. If you look up here in the command line up here, equals slope, highlight the y's, then highlight the x's, get you the slope. Equals intercept, highlight the y's, highlight the x's, gets you the y-intercept. Equals forecast, put in an x value, comma, highlight the y's, comma, highlight the x's, will tell you the y value that matches that x value. And this will work for any, pretty much any y value, any x value rally, right? It can be between in with the data, or it can be out in the future. It'll still do it for you. Okay. Now let's head back over to our chart here. Okay, so now there are some different kinds of questions out there in MyLabs Plus. I'm going to show you. I have this set up here. All right. So I'm going to go ahead and click this to show an entire question. So you'll see for this one, actually, I think I missed one there. Just a second. All right, so let's go to, say, 37. 36. There we go. So this is one of these kinds. So I've got to show the whole problem. So they give us some data here, right? And they ask us for the graphs. But if you look through this question, they never ask you for the equation, okay? So what's happening really is you're just plotting the graphs. You're eyeballing which one looks, so you just pick the one that matches the data points. You're going to eyeball which one matches the line best, okay? And you can figure out all the answers from the graphs. You don't need this tools that we got for you that we just talked about, all right? So if they give you data like this and they don't ask you for the equation of the line, you don't need to use the slope or the intercept or any of that. You can just do this plain old fashioned, right? Make your graph, look at the data, match it up with the graph, take your data off the graph, take your answers off the graphs. However, if you get one like this, here they gave you the data, and they're going to ask you for the equation of the line, right? Now you have to use the slope and intercept stuff, right? Now you will have to use it, okay? So what you would do is put these numbers right here into Excel, do your equals slope and your equals intercept. That'll give you the slope, the m, and the intercept. Put the t in there with it, and you got it. And then just the rest of this is going to be plugging stuff into the equation, get stuff out of it. Okay. So they give you data like this. That's not a perfect, clean thing, which is what's going to happen in Chapter 5, Section 4. If they ask you for the equation, you're going to have to use these tools that we got in Excel. If they don't actually ask you for the equation, you don't really need them. You can just make the graphs, be careful, take your data off the graph. All right, that is it for this one. I hope you found that helpful.